I have added a few elements to my diagram. So let's explain what's going on here. We have a 12 by 12 square. We're going to cut off 4 of these corners. This will be gone, 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 gone. And we're going to fold along these small edges. I'm going to show you one. And we'll repeat here, 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 and form a box, and the box will have a square base. And we'll actually fold along this square. This green square will become the base of the constructed box. And the length of each side of the green square has to be 12 minus 2x. And that's why I have added 12 minus 2x here, which is the length of the base of the box. And since the base is going to be a square, this has to be 12 minus 2x too. So the variable has been defined for us. The height of the box is going to be x, because I'm going to glue this edge and this edge together, let's say, to get this edge. So now, based on my drawing, I can conclude that if the height of the box is x, the length of the square base of the box has to be 12 minus 2x. So what I have here is a formula for the volume of the constructed box, and let's call it V of x. V is a function of x. The volume of the box has to be x times 12 minus 2x squared. Basically, it's length time width time height, except for 2 of the dimensions are identical, and they are 12 minus 2x. X is the height, 12 minus 2x is the length of the square base. If I perform a little bit of algebra, I'll get 4x cubed minus 48 squared plus 144x. So V of x is 4x cubed minus 48x squared plus 144x. Now, I need to find the derivative of v with regard to x, and that gives me 12x squared minus 96x plus 144. This is the derivative of x. Now I'm going to set up v prime x is equal to 0, and basically I'll solve for x. So if I say v prime of x is 0, then 12x squared minus 96x plus 144 is equal to 0. And if you simplify and factorize, you're going to get x is equal to 6 or x is equal to 2. That's what we get. Now, x is equal to 6 doesn't make a lot of sense, because if you subtract 2 times 6 from 12, you're going to get 0. So that's not a number we care about. So using the first derivative test, the second derivative test, or an appropriate graph, we can show that the function v of x reaches a maximum value at x is equal to 2. I will use the graphical method. I prefer it because it helps me see the solution better. However, you do want to know how to use and apply the first and the second derivative test to decide if a critical value is a maximum or a minimum. But graphs are always helpful. Even if you use the first derivative and the second derivative test, you should double check it with a graph. So I have graphed this function v of x. I've graphed it, and it does seem to show that the function v reaches a maximum value at around 2. So our solution x is equal to 2 is a valid solution. So our conclusion is when x is 2, the volume of the box is the largest, and when x is 2, 12 minus 2x becomes 12 minus 4 or 8, so the dimensions of the box should be 2 by 8 by 8. The question wants us to find the dimensions of the box that will maximize the volume of the box, and the answer is 2 by 8 by 8.